Thanks so much for joining me today. Great to be here at this inaugural DevOps Days. I'm Justin Reock. I live in Kissimmee, Florida. My background is primarily in software development. I wrote code for a long portion of my career, moved into sort of enterprise architecture work, but always with a focus on integrating a lot of open source technologies. One of my kind of first big successes with this was maybe 10 years ago, working with an ISP to replace probably $12 million worth of Oracle BEA WebLogic SOAP and Beeple stuff with a combination of ActiveMQ and Apache Camel, and it went over great and reduced the resource footprint and saved a bunch of money. So, you know, for me, open source, which is something that I've been evangelizing for a large portion of my career, has really always been about developer productivity, whether I knew it or not. You know, open source, I think it's easy to talk about, oh, it's free, there's no license, right? But you look at the Free Software Foundation, and what do we all know? It's free as in free speech, not free as in free beer. Or some of us are learning free as in free puppies, because it's actually a lot of work. But that freedom is what unsticks developers' ability to innovate, right? They can just get their hands on really high quality software immediately and start their work. So productivity is something that's been fascinating to me in terms of what we can do by reducing bottlenecks and friction in software. And it's what took me to Gradle to talk about the practice of developer productivity engineering. So we're gonna dive into that. So, these kids look pretty happy. They've just run a Hello World program, right? Learning how to code. I think those of us who have coded in our career may have felt similar little bits of victory. Maybe we felt it recently, right? Got something to build properly. And it probably didn't take 2 hours for your build to complete. It probably didn't take, you know, another 2 hours to debug some build failure. Certainly, I think these kids, if they'd waited 45 minutes for a Hello World to come back, they might have picked another hobby, right? So we're well beyond the Hello World application at this point. A lot of you may have seen the statistic. It was certainly accelerated as a result of COVID. But IDC predicted that by this time, 2022, roughly 65% of the global GDP would be digitally transformed. Let that sink in. 2/3 of the global GDP has software in it. Right, that's insane. Okay, it's a ton of code that has to be written. And I heard the metaphor used earlier that you know, DevOps is lifting all boats in the harbor. I think it's fair to say that software is lifting all industries, right? This was just officially announced maybe a month and a half ago. The work was actually completed back in June. The remaining 8% of the human genome has been fully decoded and mapped. Now lives in a digital twin model. It was decoded by a deep neural network, coordinated via Slack. And now we have the ability to run predictive models against our own DNA, unlocking the possibility to discover new novel pathogens before they emerge and know exactly what vaccine to print for them before they even show up in the wild. Okay? So this is serious business. And the best code is written by happy developers. So we have a responsibility to foster developer joy. Because these innovations are augmenting global innovation and solving the biggest problems facing our society. But instead, enterprise software development is just creating a whole bunch of challenges and frustrations and toil and friction for our developers instead. Ironically, as projects become more successful, as more developers get involved, as we write more source code, as there's more dependencies and transient dependencies, the developer experience deteriorates. Build times get longer. Test times get longer. It gets harder to troubleshoot, right? We can't keep an eye on how long developers are waiting for test cycles to complete or builds to complete, right? No one's really even watching it. And it's 2022, and we've done a lot of really great stuff with DevOps, and we've done a lot of really great stuff with reliability. We've unstuck a lot of bottlenecks and friction in our ability to get code out to production. So why have we ignored so much of the developer experience, especially because it's no longer the big beating the small, but the fast beating the slow? I don't need to tell this quote to this crowd. This is the rallying cry for DevOps, and it's as true now as it was years ago when Eric Pearson from Intercontinental Hotels Group first said it. So why then is this the calendar for most software engineers? All right, we get up in the morning, ready to code. We're going to code. That's what we love to do. We're in flow. We're in a state of creative flow. We're joyful. All right, the brain has been mapped while people are coding. And it's fascinating to see what's going on in there, right? Right brain thinking, left brain thinking. We're problem solving. We're creatively problem solving, but we're also hypothesizing, right? We're doing something scientific. We're saying, I think this code is going to solve the problem that I'm facing. Then I'm going to ask the computer for some feedback, and then I'm going to wait. I'm going to wait for my local build to complete, and it's going to fail. So then I'm going to spend a good hour debugging it. Am I in flow state for any of that? Am I in a state of creative flow? No, I'm frustrated, I'm stressed. It's not to say that if a build fails that it's a problem, right? That's a new problem to solve. It is a problem, that's great. But what if it takes an hour, and if I don't have the right tools to debug that failure, right? I'm out of my flow state, I'm frustrated, I'm not happy anymore, I'm not productive, I'm gonna go to lunch. Then I'm gonna come back from lunch. Yay, my build actually worked. I debugged it properly, I'm gonna send it off to CI. I'm so excited. Oh, the tests that were passing in my local environment, they're acting flaky in my CI environment. Now I get to go debug a flaky test for the rest of the day. All right, we can do so much better than this. And it's not just me theorizing about this. We've run our own, whatever you call it, social proof campaigns, and found that overwhelmingly, developers that we've surveyed in the enterprise, 92%, before they've looked at developer productivity engineering, have spent too much time waiting on build and test feedback either locally or during CI, right after this inability to easily troubleshoot and determine the root cause of builds, tests, and CI failures. Okay, so this isn't, we think this might be a problem. No, we're definitely hearing this. So that's why we think that this process of developer productivity engineering, or what we're calling DPE, is the next set of bottlenecks to clear after DevOps. Okay? Now that doesn't mean, that you have to wait for your organization to become DevOps mature before you can start looking at, what goes into developer productivity engineering. It's just that this is a new-ish mindset, right? Netflix just started a developer productivity team in 2017. Okay, it's relatively new, but it's a center of excellence now, only focused on developer productivity. LinkedIn has a similar group called their Developer Happiness Organization. Also, very new, 2018. Okay, so the consciousness of the industry is now shifting closer and closer to the developer experience. So we think then that developer productivity engineering really is the next big thing after DevOps, because we think it's the next logical set of bottlenecks to clear. Okay, it's a constraints-based way of thinking, similar to some of these other practices that you see up here, like Agile, Lean Six Sigma, business process reengineering. Anyone familiar with the goal or the theory of constraints, or the Phoenix Project? If you've read that, if you haven't, I highly recommend it. It'll change the way you think about your business value writing software. So developer productivity engineering is also rooted deeply in constraints-based thinking. We are looking at ways to use technology to increase the throughput of a developer organization while decreasing its cost. And it takes an engineering approach to productivity. Right? This isn't people management. Okay? This is systems management. We use acceleration and analytic technologies to improve the developer experience. Okay? So this isn't about leaning on developers to try to crank out more code. We know those are vanity metrics anyway, right? And this isn't even about like IDE tooling and shortcuts, right? This is really about applying telemetry and observability to the tools that developers are using to build their code, to ensure that we can apply technology to make sure that the build and the test feedback cycles aren't just fast enough, right? But they're as fast as they can possibly be given all applied technology, analytics, and observability, okay? And it aligns with strategic management goals. It's actually not too hard to get your boss to buy in to looking into this because it leads to a faster time to market, a reduced cost, and an improved quality. Let's make sure that we're not talking about, like I said before, sort of traditional developer productivity management, right? We're not focused on people, we're focused on process and technology, which means that we're not really basing our metrics on activity, we're basing them on outcomes, right? Did the average local build time go down significantly for all developers in the organization after applying these techniques? Can we prove that? Is it staying fast, right? So the SDL focus is really on sort of CI, or the build and test aspect right now. It'll change, right? All kinds of interesting stuff is happening now, trying to get working code into production as fast as possible with limited bottlenecks. So we service mesh and all that kind of stuff. We're starting to see really safe ways to do canary releases and stuff. So we may need to start thinking about how we observe, in some cases, parts of the deploy. But for now, it's really just the build and test. So our ROI is very hard and proven when you start implementing these things, right? Developers were waiting an hour for the build. Now they're waiting 5 minutes. Right? Netflix's productivity team, by implementing developer productivity engineering, has famously taken their Android app from a 64-minute build time down to under 5 minutes. Okay? Clean builds, all tests, everything. All right? Netflix developers can now get all that build and test feedback in less than 5 minutes. That's done wonders. You'll see the app will be more and more stable. Of course, it aligns with our C-level objectives as well. Everything down here, like slow builds, feedback cycles, bubbles all the way up to time to market, productivity, all the way up to revenue, cost, and brand. Again, it's just not too hard to convince your boss to invest in this stuff. So let's be clear about the problem that we're trying to solve. I really love this picture. In fact, if you kind of go away with the what is developer productivity engineering trying to solve, just take this one kind of picture in your mind. If you can imagine, all these little things represent feedback cycles. The developer waiting on a build to complete or a test cycle to complete. Sometimes they're fine, right? And these are happening in local environments, remote, and CI. So when you're observing this stuff, you want to take all environments into account. Sometimes the feedback cycle just takes too long. Okay, I feel like we can address that. Sometimes takes too long to fix. Right? Maybe we don't have the best troubleshooting tools available. Maybe we're copying and pasting from a whole bunch of areas in the system into Slack or something with build engineers trying to figure out what's going on. This one, sometimes it could have been prevented altogether. That's the worst one. Okay, when there's failures, build failures that may be impacting multiple developers in the organization, but they're just not being observed. And developers, again, it is just staggering the amount of toil and friction they'll put up with, right? So it's up to development leaders, platform leaders, to make sure that developers don't have to put up with a lot of these avoidable problems. And we'll talk about what some of those are. 81% of IT professionals agree that developer productivity engineering's impact on their tool chain made their job more enjoyable. No big surprises there, right? If you're not wrestling with your tool chain and waiting sometimes hours to get feedback, to have the computer answer the hypothesis as to whether or not you did the right thing, you're going to be happier. So when we look at the pillars of developer productivity engineering, when we look at what pains we're trying to solve, things actually become very pragmatic. All right, so I've said some idealistic things up here, right? Developer flow is very important. Software development is a state of creative flow. It's been mapped. We can see all types of crazy neurochemistry going on while people are writing code. There's an ecstatic and joyous and dopamine-laden experience there, as long as it's not interrupted. Okay, so first thing we are then pragmatically addressing from our idealism is idle and wait time. Make things faster. Make the builds faster, make the test cycles faster. Great. Caching. So you'll see a number of build tools trending in this direction now. Bazel most recently has come out with a build cache. Right? These are not dependency caches, so don't conflate them with like an Artifactory or a Nexus or something like that. Right? These are actually caches that are part of the build process itself. So a lot of build tools these days, Gradle, Bazel, Maven now with Gradle Enterprise extensions, are incremental, right? They do part of the build, and if the inputs to that build haven't changed, well, they can just pull the output from that build from cache as opposed to running that part of the build again. Actually works pretty well and elegantly, and you can look into it. So that's number one. Let's avoid work in the build and test cycle by providing a cache for tasks, goals, or targets during the build so that we don't have to repeat them during a clean build in the next run if we haven't actually changed code that would change those outputs. The next one that's not on this list, I'll talk about a little bit, is predictive test selection. This is an ML-driven way of redoing your test impact analysis strategy, right? So in test impact analysis, we try to say, okay, we changed this code or we changed these objects, so now we have to run these tests. But I think a lot of you who have ever been forced to do selection by hand, who have said, oh, I don't have time to run all these tests right now, but actually I think they're all just going to pass anyway because I didn't change anything that modified that. We've all kind of been there if you're dealing with an application that has lots of tests. Predictive says, why not just apply machine learning to that same set of criteria instead? And so we use a gradient boosted, we recommend a gradient boosted model, not a deep learning model. That way you don't have to install a bunch of like GPUs in your CI/CD chain or whatever, but you can do some real learning that will say, okay, based on the history of changes in the past, and then comparing that to the changes that were just made, yeah, I think only these tests are the ones that might fail or produce some interesting feedback, so I'm just gonna skip everything else. So that's predictive test selection. And then, so we've found two ways to avoid work: caching, ML, and then whatever still has to be done, it's usually still testing at that point, it needs to be done, especially in large test suites. Let's distribute those tests across multiple parallel agents. Let's bring in the consumer fan-out pattern. So great, now things are faster. What about faster troubleshooting? Well, we need something that can pull all of the forensic data about the build into one place that's viewable, navigable, and shareable, right? So just talking about an observation platform in the last talk, we're effectively saying provide that same observability to the build pipeline. How many people here could tell me with any certainty or accuracy about how long your average builds take? 35 minutes, he knows. He's probably tracking them. Anybody else? See? Why? We're not even looking at it, right? We were selling to BMW, and it was a really easy sell. This was a couple of years ago, trying to sell them developer productivity engineering. We just said, are you tracking your local build times for the apps and website that you're working on? No. Well, what do you think would happen if you went to your auto manufacturing factory and told them that you weren't tracking this? And they kind of said, oh boy, that's a good point. Yeah, but we don't think about it, right? It's a new consciousness for the industry, okay? So we say, observe local build times, CI build times, observe failures, right? Build failures. Find out how long your developers are taking to wait to encounter those failures. See if those failures are avoidable, right? So the observation then begins with a build scan. Now, if you want to try one of these for free and you happen to be a Gradle or Maven user, we have our open source Gradle build scans, right? They've been part of the open source build tool forever. They were added a couple of years ago to the Maven build tool as well. Check out scans.gradle.com if you want to have an idea of what kind of data we recommend pulling out of there. Again, totally free, part of the open source product. Next thing then, failure analytics. So we mentioned widespread failures across the organization that could be costing developers time. Let's suss them up, put them in one place, stick them on a dashboard, and start eliminating them, right? How long are they taking to encounter? 20 minutes? How many developers are encountering them weekly? 100? Well, that's a problem. Let's go ahead and eliminate that and remove that toil from the pipeline. Then let's watch it to make sure it really had an impact. Also, this gives us a great ability to detect flaky tests, okay? Tests that are non-deterministic. Under the same conditions, sometimes they pass, sometimes they fail. We're going to get into them a little bit more, but this is a great platform to be able to start sussing that out. We, the Gradle build tool folks, the open source Gradle build tool folks, schedule monthly flaky test days where they just open up the flaky test dashboard and they say, okay, which tests have been the flakiest over the last month? And they just fix them until they're gone. It does wonders for their development experience. And then, of course, a single fix on speed isn't going to fix us forever, so we want to make sure we're paying attention to trends and insights here. We want to make sure that we are continuing to observe, as we know in DevOps, and so that something weird happens, like a new annotation processor or some new endpoint security, and suddenly local builds are taking twice as long as they were before, that somebody's watching that, proactively doing something about it. Final tier really isn't productivity, it's about CI costs, but if we're avoiding all this work over here, we're also avoiding it in CI, and so your CI pipeline is going to be cheaper. All right, where are we time-wise here? Oh, we're pretty good. So very fast feedback cycles are important, all right, they have a kind of wonderful cascading impact to the entire business. On one hand, when developers are able to realize faster feedback cycles, there's just less idle wait time. I think we've beaten that one enough, right? Developers don't have to wait as long for their builds to complete or their test cycles to complete, so they can realize whether their hypothesis they made in code was correct or not faster. So there's less context switching. That's what's going on here, right? Now, if you're going to wait an hour for a build to complete, most of us aren't just going to sit there twiddling our thumbs, right? We've learned this. We've been in the industry for a while. We know when to go get coffee, or we know when to go start on some other task. But we also know that takes 15 or 20 minutes of cost to really be effective in the next task that we're doing. We also know that context switching is not good for our brains. There's been a lot of research over the last couple of years that suggests that it can actually be deleterious to the executive functioning of the brain. So then we end up with what? More focused developers, higher quality product, and better productivity. What else do we get? Well, developers can build more often. All right? So if I've got an hour-long build, what's my tendency? Cram a bunch of stuff in there, right? Spend a lot of time, and then send it all off. More breakpoints, more merge conflicts, just greater chance of failure and more debugging. So more efficient troubleshooting, faster mean time to resolve. Again, this comes all the way back to quality and productivity. All right, so this one thing, just keeping developers in a better state of flow and reducing their idle and wait time, has these enormous cascading impacts we've found to the productivity and quality of the business. So also sometimes the numbers aren't quite what you would think. Take, say, a week span of time. A team of 11 with a reasonably healthy build time, 4 minutes doesn't seem terrible to me, can, say in a week, maybe build their code about 850 times. They can ask for feedback about, let's say, 850 times in that unit of time. What is a day, week, doesn't really matter. This is kind of hypothetical. The numbers bear out that a smaller team of 6 with a quarter of the build time, so 1 minute as opposed to 4 minutes, will actually be able to build their code significantly more often, almost 25% more often in that same span of time. Smaller team with a shorter build time. So a couple of things going on here. First of all, 4-minute build times can be better. And there's an impact when they are better. So we need to get out of this mentality of, is the build fast enough? And get back into the mentality of, is it as fast as it can possibly be given all acceleration technologies, analytics, and observation? That's the right question to be asking. Because 4 minutes is actually kind of toxic. There's no room for a context switch in 4 minutes. So developers are just going to sit there, not do anything. Maybe get distracted by a Slack message or an email and even abandon the work altogether, who knows? But that's not going to be productive time. So if we could take that 4 minutes down to 1 minute, well, it could have a huge impact in how often developers are actually asking for feedback. And what about that 1 minute team at scale? 6 developers with 1,000 builds a week, with a 1 minute build time, taking it down to 0.6 minutes, can save 44 days of engineering value a year. For a small team of 6, that's huge. Okay, a large team, 12,000 builds a week with 100 developers, taking a build just 4 minutes down from 9 minutes to 5 minutes, 5,200 days of engineering value returned back to that organization. Is it perfect math? No, but if you take that every hour would involve 2 context switches, one to get out of working on the code and one to get back in it, that's like 30 to 40 minutes of that hour spent context switching. Okay. So we talked about build caching. Just real quick, introduced to the open source tool, by the open source tool to Java in 2017. It is available as part of a Gradle build, if you're using Gradle. Also available in other build tools as well. The point is to look for it, right? If you're looking at Bazel, for instance, if you're looking at the Bazel build tool right now, it also has a build cache. Okay, not a dependency cache. It's the main thing I want to take away from this. It's complementary to a dependency cache like an Artifactory or a Nexus, but it solves a different problem. Effectively, inputs to the build can create a cryptographic key. The outputs from the build, which are usually compiled class files stored in some type of little folder, can be stored in cache against that key. And if the same conditions and inputs are ever pushed in again, we can retrieve the work from cache as opposed to having to run it again. Boom, save time there. Build scans can speed up troubleshooting, providing this shareable build summary, sort of like a forensic, I like to say MRI more than X-ray of the whole build process. Very easy to spot bugs here and self-service to the developer. And even integrates with like Jenkins and other pipeline tools that are aware of Gradle or Maven. Effectively, you can just add the build scan directive to the open source Gradle build tool, which is -- scan, or make some changes to the build file. Or you can add the build scan extension to your Maven build, also freely redistributable, open source, available over Maven Central. And when your builds run, they'll publish these scans, and they'll publish a URL that you'll be able to look at to go and check out all that forensic data. And if your CI supports it, it'll be right there, the link just available for developers to click on, so totally self-service. The idea here, whether you use Gradle, Maven, Bazel, any of these things that support a build scan or not, is to have this kind of functionality. And really what it comes down to is that it's comprehensive, right? It has everything that happened in the build. Console log output, switches, infrastructure details. If you're a Java thing, I want to know the JVM details. I want to know the version. I want to know the heap size. I want to know the operating system it was running on. I want to see all the environment variables that were present. If there were any custom values sent in, I want to see those too. And then I want all of it to be shareable. I want to be able to make any of that click to a little link that I can pass into Slack to give to a build engineer that I'm troubleshooting with so that I can go on with my day. Okay? So whether you use a build scan or not, it's that type of functionality that's essential to be developer productivity engineering compliant when we deal with faster troubleshooting. Test distribution makes tests even faster. This is the execution of multiple stateless tests at once in parallel. There are a number of platforms that are available that will let you do this. It's taking a pattern that we already know to work in this space and applying it to testing. So again, going back to developer productivity engineering, applying all possible technologies. We have caching to avoid work through traditional caching. We have predictive test selection to rethink the way we do test impact analysis using machine learning. And then any work that still has to be done should be distributed across multiple agents. And then finally, kind of once we've hit these acceleration parts of the optimization that we want to do for developer productivity engineering, well, we have to keep looking at things. So we saw before that, tracking local build times and keeping track of them is not a common practice for most organizations. No one should feel bad about this, by the way. I merely say it to point it out. I want to reinforce that Netflix only began their productivity team like 4 years ago, a little over 4 years ago. This is Netflix. Right, this is new for big Silicon Valley companies, right? In less than 5 years. But I think what we're learning now is that this practice is not just for big Silicon Valley companies, right? Everyone can benefit from engineering a better experience for the developers, and it starts with watching. It starts with just looking. I used to have what gets measured gets improved here, the Peter Drucker quote, but it's getting a little tired at this point, I think. Without focus, problems can sneak right back in, all right? All the same things that took our wonderful, tight, healthy little project and made it a build nightmare can continue to happen, right? Infrastructure changes, different means of doing binary management, new annotation processors, versions of annotation processors, build logic configuration settings, new office locations when the world comes back to normal again, code refactoring, endpoint security we've even seen. All of these things can have an impact on the time it's taking for developers to wait to get their feedback cycles and then risk being brought out of flow. So we want to make sure that we encourage continuous improvement. Failure analytics, take all the failures, the build failures that are happening across the build pipeline, put them in one place, centralize them against the type of failure, the developers, the number of developers experiencing that failure, and ideally the amount of time the developers had to wait in the build to encounter that failure. Because what happens next? We have this nice dashboard that's saying, oh gosh, this one failure in the build is impacting 100 developers a week, and they're waiting 15 minutes to get the failure. Maybe we should investigate that. Maybe we should make sure that developers don't run into this anymore. And the same is true for Flaky Tests. And then trends and insights. So, Flaky Tests. This is not my quote. This is Spotify's quote. They call Flaky Tests the infinite pit of sorrow. All right? Again, what's a flaky test? It's a test that runs and like fails or something. Then we're like, what do most developers do? What do we always do when it fails? And run it again, okay? Same conditions. Oh, succeeded. Oh, wonderful, great. I'm gonna pass it off to C. Yeah, no problem, nothing to see here, right? That is the psychology, and that's exactly why Spotify says that literally any bit of jankiness you see in their app these days that's not bandwidth related can be traced back to a flaky test somewhere. Okay, they cause problems all over the place, right? Developers have to wrestle with them, build engineers have to wrestle with them. They even poison our machine learning models. I mentioned before we have this predictive test selection that learns from test history how to react to certain changes in the code. What's that model supposed to be doing if it's trained on flaky tests, right? It's going to be getting garbage data, right? So it causes problems all over the place. And we can suss them out, right? If we can already trap inputs to a task, for instance, and we can trap inputs to a test task, well, then we can say, okay, under this exact same condition, sometimes the test fails, sometimes it succeeds. It's flaky. Stick it on a dashboard. Someone should do something. Okay. And then finally, enterprise toolchain management should be centralizing all of these metrics, right? You're watching your production machines, and they're expensive resources and they're important. Watch your developers' machines, all right? Your developers are the most important resources that you have. Make sure that they're happy. Make sure that you're doing everything you can to watch their happiness, observe their experience. You can tell a story about how they're feeling just by looking at failures and build times and test times. And of course, machine learning will lead us all to greater efficiencies. So we talked about this one already, but you know, something that was developed at Facebook. It's not our tech. But the idea is that we want to look at code changes and characteristics to accurately predict which tests are interesting. What does interesting mean? It means it's probably going to fail. Okay. You can go back actually to 2014 in all fairness and start seeing a bunch of academic white papers about this algorithm. Very fascinating stuff and works really, really well. I mean, we're seeing on well-trained models 99.6, 99.7% confidence in detecting that a test is going to fail, which is the most important part, right? It's saying, okay, I got 10,000 tests I'm going to run. 3 of them are going to fail. I'm just going to run those 3, skip the rest of them. Sounds scary. Post-merge, you want to run all tests and all that kind of stuff, but it really saves a lot of time in the local experience. So I think that developer productivity engineering will become standard practice, right? I think you're going to see more and more companies really thinking about how can we put a center of excellence or a PMO together that's only focused on engineering the best experience that we can for our developers, because the world should foster developer joy. The best organizations who are doing this, by the way, build focus teams. I mentioned that a little bit. But you can look here at some of the companies that have already done this. I mentioned Netflix and LinkedIn already. They're some of the more ones who are sort of famously doing this. Twitter has had a developer productivity team in place since around 2018, the same time. SoundCloud as well. Again, the best practice here is to start thinking about these metrics and thinking about these solutions and then centralizing it. Don't make it the part-time job of your lead senior software developer to think about productivity, right? It won't happen, right? Make it someone's full-time job. If you want to learn some more, we've got tons of information available on this practice at our Learning Center at Gradle.com. Most of the Learning Center, the stuff that you're going to see there around developer productivity engineering is intentionally kind of vendorless, right? We really want this practice to be established. We welcome the competition. I mean, there's a lot of different platforms and languages that are non-JVM that deserve this type of attention, right? So intentionally, a lot of the material that we have out there is sort of vendorless. So please check us out, take a look at what we've got. We do have a book on this, second revision. Third is in planning with O'Reilly as we speak, physical copy. But right now, this is in a second revision. You'll see Gradle on the front cover, and that's it. Again, this is a vendorless book that will teach you the practice of developer productivity engineering. It's an 81-page ebook right now. I would just ask yourself, what if you were the person who brought DevOps into your organization 10 years ago, 5 years ago? What does that do for your career? What does that do for the success of your business? I say this is an opportunity to do that again. It's an opportunity to be that person again. We have a new practice that's solving real bottlenecks and creating real value for businesses, and it's new. right? So you can go and grab the manual, check it out, see if it's for you. My next webinar will be to talk specifically about predictive test selection with the principal architect, Eric Wendelin, that you see here at Gradle, who actually developed it for us. You can find it linked off of our site if you're interested in learning more about that. I'll also be giving this same talk next week in Aarhus, Denmark for DevOps Days. So we're really going big on DevOps Days this year and very excited to be involved. So thanks very much. I really appreciate the time and attention. Feel free to reach out and be here for the rest of the show.
Big round of applause. Thank you.